Hello, hello, friends and family. My name is Kanda, and today we'll be looking at grade 8, that is junior secondary. I'll be looking at mathematics. Sorry about that. We'll be looking at mathematics, and in particular, we'll be looking at angles. Allow me to set the camera nicely as we sit down. We'll be looking at grade 8 angles, but some teachers teach this topic in grade 9. And yeah, so the first thing first, do not forget to subscribe to my YouTube channel so next time I go live, you will be notified on what is happening. And the second thing is on the description of this video, I have attached the document that we'll be discussing today in English. So I urge you to go to the description of the video, subscribe to the channel, as well as download the pictures. There are about 3 pictures that I've sent of the document that we'll be discussing today. So without wasting my time, like I said, we'll be looking at angles in mathematics. And under angles, there are 3 things that we're going to look at. One, we'll be looking at complementary angles. Complementary angles. The second one will be supplementary angles. The other one will be supplementary angles. And then the supplementary angles. Then the third and last one, we'll look at angles, if time allows. Angles associated with triangles. So those are the agendas for today. The first thing, look at complementary angles. Which ones are complementary angles? And when you hear the word complementary angles, what does that tell us? Okay, the other one, supplementary angles. When you hear the word supplementary angles, what type of angles are they, and what information do we get from them? And the last one is angles associated with the triangles, where we'll look at types of triangles as well as the angles associated therewith. And then thereafter, of course, some assessment will be given to review the understanding of today's lesson. So allow me to clear the board so that we start with the lessons. Okay. So those are things we are going to do today. I'll be a little bit brief. At the same time, I will be taking time to make sure that everyone understands. So those are 3 things we're going to look at: supplementary angles, complementary angles, as well as angles associated with the triangles. I must have another thing to use to dry up the board. Okay. Sorry about that. So yes, sorry about that. Now you see, angles are a very, very, very important topic because we apply angles in many aspects of life. Where do we apply angles? I'm trying to give a rationale on the topic. In construction, we follow angles in many ways. Okay, If you don't follow the angles, you end up having the wall meeting at the top. Or maybe you find that if you don't observe angles, you end up having the walls like that. There are many ways, of course, when you are making the roof, we observe the angles and many other things. Okay? Even when you are turning, you as a driver, you're trying to make a turn, getting home, of course, we have to observe the angles, looking at the length of the vehicle as well as the space on the road. So we apply angles in many, many aspects of life. So it's important that we understand the angles. So without wasting much of the time, we're going to look at these angles, which are listed on, and the first type of angles that we're going to look at are called complementary angles. Complementary angles. Now, when you hear of the word complementary angles, what type of angles are they? Now, these angles, we can say that these are the angles that, or can say angles that add up to 90 degrees. Okay, so complementary angles can be 2, can be 3, can be 4, but those angles, when we add them, the maximum that we can get, the maximum value that we can get is 90 degrees. What does it mean? They may give you few angles, hide some more, and then they ask you to find hidden angles. But for as long as we know the angles, we're talking about a supplementary, complementary angles. One thing you know for sure is that they must be equated to 90 degrees. Okay, so maybe let's look at example. I'll just be giving one example each, unless otherwise. So we can look at and most of the times they put that as a symbol for 90 degrees. So let's say if this is the complementary angle, and then they divide a line, like they divide the angle like that, having, let's say this angle is 2x and this angle there is x. Then they say find the value of x. Now you see that which we have. They've given us they have not told us the maximum, but for as long as we know the symbol here, it's talking about the 90 degrees, which is the complementary we're talking about. Now they've just given us two portions within the 90 degrees. They've given us x, the other one is 2x. So when they say that and ask us to find the value of x, what are we supposed to do? Remember, the maximum value of this angle is 90 degrees because these are complementary angles. So what do? We go add these two, and then we equate to 90 because that's the maximum value. So I'm saying when there is x, we add to another 2x. The sum or the total is supposed to be 90 degrees because these are complementary angles. So this angle plus that angle, when we add them, supposed to give us 90. So what do we do here? We're going to add 2 here. There is 1x plus 2x. We've got 2 values of x and 1 value of x. When we add them, they will give us 3x. But that must be equal to 90 degrees. Now, what does that mean? What it means is that there is a value of x which we don't know, in so much that when we multiply it with a 3, it's supposed to give us 90. Yeah, there is a value of x here which we don't know, but one thing we know for sure is that when that value of x is multiplied with a 3, it's supposed to give us 90. So here we can just divide by 3 and divide by 3 here. These values, these 3 and the values, the 3 and 3 will cancel, and then getting to have x remaining alone because that's the value we're looking for. But how many times can 3 go in 90? It can only go there 30 times. So that means the value of x is 30. Of course, there are people who always want to prove because mathematics has to be proven, even science has to be proven. proven. So let's see if the value of x for sure can be 30. So we'll come back to this, where we said x plus 2x supposed to give us 90. So now we need to verify if when we put 30 here, where there is x, we see if we don't get a 90. So where we're good as x here, we're gonna put a 30. So say 30 plus, remember, when you have 2x, meaning you're multiplying 2 with the value of x, and what is the value of x this time around? Is 30. So we're gonna put a 30 here. We see what it will give us. So we're gonna have a 30 plus 2 times 30 gives us 60, and when we add that, it gives us 90 degrees. That means the value of x is perfectly well. So that is the first example we can look at from the complementary angles. Just that. All in all, for as long as you see that, you should know that the maximum value of angles is 90 degrees because these are complementary angles. Make sure you go in the description of the video and download the document which contains these examples so that you just dedicate this time to listening or knowing the fact that you have these with you. So just one example for complementary angles, I think is okay. We can go to the other type of angles. Remember, I said there are only 3 things that we're going to look at. We have complementary, which we have just looked at. The other one is supplementary. And then the other one is angles associated with angles. So those are the things we're going to look at today. So, do not forget that complementary angles, they have a maximum value of 90. So now we will look at supplementary. We'll look at supplementary angles. Now, supplementary angles, what types of angles are they? So these are angles that add up to 180 degrees. Supplementary angles are angles that add up to 180 degrees. That is the first point I can bring out. Okay, this is the first point. Okay, allow me to use this as B. And then if we say these are angles that add up to 180, but you see how many 90s are in 180? There are 2. So we can say 2 complementary angles, complementary angles add, okay, 2 complementary angles are equal to a supplementary angle. Supplementary. These are points I'm trying to give to you for instance. These are angles that add up to 180, but in 180, there are 2 90s. So we're saying 2 complementary angles, meaning 2 90s will give us 180. The other point is that these angles are associated with a straight line. A straight line. And an illustration is that if this is a straight line, when you have this as your line, this angle A here and angle B, when we add them, supposed to give us 180. That is the point I meant to say. They are associated with a straight line. Angles on a straight line, they add up to 180. So these points are very, very much important. when we're looking at supplementary angles. Let me talk more about supplementary angles. Where do you find these supplementary angles? Or how sure are we that there must be an instrument that is designed, there must be an instrument that is designed in so much that the maximum angle that we can get from that instrument is 180, which is a supplementary, which are supplementary angles. Where there is an instrument we call protractor. Protractor. This is a construction, a geometrical construction instrument. It's a semicircular kind of arrangement. I'm sure we know it. And then it has, they of course, there are types. Here we have a 90. It depends. Yeah, we have a 90, and then here we have a 30, and then here we have a 60. Of course, here we have 120, and then here, okay, 90 plus 30, that's, yeah, plus that. Okay, and then here about 180, 150. So this thing here, if this is a zero, and then you have a mark here. This is a zero when you go in an anti-clockwise way, 0 up to the last end of the straight line, it's 180. And the protractor is one of the instruments that deals with a supplementary angle. Okay, so now how do you make use of supplementary angles in trying to find the value, in trying to find, trying to solve the first step? Okay, then I see how we can use the supplementary angles to solve situations. So we have an example here. Of course, there are two examples. Example number one, we have a straight line like that, okay? And then we have this thing, I'm sure it must be familiar by now, okay? And they've told us here that the value here is 2x. And here, the value is x and the value is x. And then they say find x. So how can we use the principle of supplementary angles to find the value of x? Sorry, friends, there are two methods that we can use here. Two, of course. The first one is that if you want, you can ignore this part and just take the fact that that is a complementary angle where the 90 degrees has been divided by 2. So this must be 45 and that must be 45 without wasting much of the time. But if you want, you can take a supplementary way where you say that the 2x here, this angle, you add to another x here, you add to another one here, must give us 180 because this is a supplementary angle. With all that said, 2x plus another x, 3x, plus another one, here 4x. And when you equate that, gives 180. We're finding the value of x here, so we divide by 4, we divide by 4, so that the value of x will be, okay, so here, friends, 4 into 4, 1, 4 into 18, to just go up to 16, 4 times 16, the remainder is 2, and 4 into 20 gives us 5. So the value of x is 45 degrees. That is example number one from supplementary angles. The other one is okay. The other one, if you can just allow me to wrap the top part of it, because there's also x that is asked to find, so that statement remains. So we can just wrap here and see how we can use supplementary methods to find the value of x. So 2 We have 120 here. Here is 2x. Then they ask us to find the value of x. But one thing we know for sure is that this angle 120 is bigger than 2x, looking at the way it is. So here we go. This angle 2x, when we add 220, the total must be 180 because these two are supplementary angles. Yeah, but of course these ones are unlike terms. You can't add them. The best thing I can do to get this guy, take the other side because this guy is just a constant, just a number, and this thing is just a number. So put them together. So here we'll have 2x. This guy goes there. The next thing will be an equal sign. Now this 120 is positive. Crossing over the equal sign goes there, it becomes minus. So we're gonna have 180 minus 120, and that gives us 60, right? Then we divide by 2, and the value of x is gonna be 30. So the value of x is 30. Remember, mathematics and the problem, how do we prove? So I'm gonna say 2x. So here, where there is x, we're gonna put now a 30. So 2 times 30 will give us 60. 60 plus 120 gives us 180. Therefore, the value of x is equal to 30. Okay, so those are the two examples that we can look at. Now let's see how far we can go with the angles associated with the triangles. So if you have a question from the presentation, you can just send me a text there on the chat. Of course, I'll be able to see and address it. Now, let's see the angles that are associated with triangles as our last part for today. Angles associated with triangles. So the angles that are associated with the triangles, let's look at the triangles. Now, there are certain things that we use as short ways of representing something. One, mostly we use the word mono. Carbon monoxide, meaning carbon 1 and mono 1 oxide. Then 2, we use di. Carbon dioxide, meaning 1 carbon and 2 oxide radicals. Then 3, we use tri. Trimethylpropene. Tri means 3. So triangles, we're talking about a plane figure that has got 3 interior angles. Now, these triangles are in types. So the first thing that we need to do is to understand the types of triangles. Type number 1 is called equilateral. Equilateral comes from the word equal. The equilateral is a triangle where all the sides are equal. So this is an example of an equilateral. Now allow me to bring my camera a little bit closer as we look at the types of triangles, just for now. So you see this, the way this triangle is drawn, we have line AB, AC, and CB, they have put those. They mean the fact that those lines are equal. So if all the lines of all the dimensions of the triangle are equal, therefore even the interior angles must be equal. Yeah, that's what it means. Now you see, if a triangle, and I forgot, of course, I was supposed to mention, or I might mention it later, the sum of angles inside of the triangle is 180. regardless of the way it's drawn, regardless of its type, the sum of angles inside of a triangle is, okay, so it's way too high. The sum is 180. But because there are 3 equal sides, so you find that each angle inside of an equilateral triangle must add up to 60. Because regardless of the type, the sum of the interior angles must be 180. But we're saying that these 3 which are here, they are equal. So just divide by 3 to give us 60. So here there's 60, 60, 60 gives us the total of 180. First one, equilateral. There is also another type. Where only 2 sides are equal, the other one is different. So this is the one right over here. And what name is given to this triangle where 2 sides are equal? This one is called isosceles. It's called, the name is right over here, but I'll write it here. Isosceles. An isosceles triangle is a triangle which has 2 of the adjacent sides that are equal. And if 2 adjacent sides that are equal, allow me to bring this because very important. If 2 adjacent sides are equal, meaning the angles, their base angles must also be equal. 2 lines equal, producing 2 equal angles. Like now example, line AC and line BC, they are equal, making these angles also equal. That is the second type of triangles. The third one is maybe written in any form, but the truth of the matter is that this triangle has got a specific feature. This triangle has a specific feature, and that feature is this thing you see here. And remember, when we're looking at complementary angles, we say the maximum is 90. So what it means is that one of the inside angles of this triangle must be 90 degrees. And that is called right angled triangle. Now when they say right angled, the right angle is this angle here. So that is the third type of triangles. We have the last one. This one is just unique. It's just in its own world. Why? Because none of the sides are equal and none of the angles inside are equal. Everything is different. And none of the angles add up to 90. This one is unique in the fact that, in the sense that all the sides are different and all the angles are different, and this is called a scalene triangle. So there are 4 types of triangles. The first one was an equilateral where all the sides are equal and all interior angles are equal. Second one was an isosceles where only 2 sides are equal and 2 of the interior angles are equal. Third and second last was a right angled triangle, which is right over here. Okay, allow me to go through. The first one was an equilateral, all the sides are equal and all the interior angles are equal. Second one is an isosceles, where 2 adjacent sides are equal, producing 2 equal base angles. Third and second last was right angle triangle, where one of the interior angles is adding up to 90. But take note that the 90 degrees may be here, maybe there. It doesn't really matter where the 90 degrees gets to be. Fourth and the last one, but not the least, is a scalene where all the sides are different and all the interior angles are different, and none of these angles goes up to 90 degrees. Also, none of these interior angles is equal to 90 degrees. We can have more than that, You can have less than 90, but the truth of the matter is that all the angles are different. And I'm sure this is the easiest triangle to draw, isn't it? Because you can just close your eyes and put three dots on the paper, join them, and of course you can get that. All right. So now we get back to business. Where I'm gonna say something which I just said, that the sum of angles inside of the triangle, they go up to 180. The sum of angles inside of the triangle, they go up to 180. But do not say it is also a supplementary angle. Of course, it may be, because supplementary angles go up to 180, but this is a specific feature where we're just interested in triangles and nothing more, nothing less. So let us look at the examples that we have. So we have a few examples, one or two, and then we call it a day. So now remember, the angles that we looked at, they were being denoted by letters. Find y, find x. But let me show you another way in which angles may be written. When you have 2 points, when you have 3 points, this point here, that point, that point. When these points are joined by the means of a line, you just draw 2 lines. Okay, let's say if this is A here, point A, point B, point C. Then just join 2 points. Let's say point C and F, as well as point B and N. Now you see, we have produced 2 lines. 2 lines that are joined. Now, for as long as these 2 lines that are joined are not forming a straight line, for as long as they're not forming a straight line, they are likely to make an angle. And most of the time, this angle may be denoted as theta. So that is the angle, but there is no letter. Now, how do we get to know the angle that we're dealing with? So we are interested in the points. So which points do we have around here? We have B, A, C. So we have B, A, C, or A, we have B, A, C, or A, I don't know, B, A, C, or C, A, B. So this you can also say it as Z, C, A, B. So this is one way of representing the angles. So if here we have a letter which is X, we can say that angle BAC is equal to X. Because at times they may not give you letters, they will use these symbols. And most of the times they like putting that to represent the point where the angle is. Okay, so with all that said, let us look at the example. Let us look at the example. Let us look at 2 or 3 examples that we have, and then we call it a day. So the first one says, among examples, we have a triangle which is drawn like that. I'm not interested in the type. We can put A here. The angle here is X. We have here, this angle here is X plus 65. Then we have this is C. We also have B here, and the angle is X plus 10. Then they say find the value of X. At A, X, at C, X plus 65, and then at B, X plus 10. How do we find the value of X? The truth of the matter is that these angles inside, they must go only up to 180. So we're going to add them. X, the angle at A, plus the angle at B is X plus 10, plus the angle at C is X plus 65. But the sum total must be 180. So that x and x and x, we're going to have 3 x's and then we have 3x. Okay, plus 10 and 65 will give us 75. And the sum total has to be 180. Just like we did. These guys are like terms, you can't add them. The best that we do is taking this guy the other side. So we're going to have 3x is equal to 180 minus 75, and that will give us 105, I perceive. Finding the value of x, we divide by 3 here, we divide by 3, and you will find that the value of x here, when you divide 3 into 10 is 3 times, remember 1, 3 into 15, 5. So the value of x is 35 degrees. Very simple. Okay. The second last, two more examples. These ones, two more examples will be this is example 2. So we have a triangle drawn like that. We have A, B, C with these symbols, given that the angle there is 15 degrees. Okay, then they say find angle B. They just put that, you know that they're looking for the angle at point A, and the angle you're looking for is this point. But you see, there's no data, we don't even know what to do. The truth of the matter is that we know the type of a triangle that is an isosceles. And if it is an isosceles, this line and that line, they are equal, making sure that these angles are also equal. Okay, we're here going to combine a little bit of some theories. One thing we know for sure is that the angle here and angle here are equal. So we're going to say angle BAC. We say BAC is equal to angle ABC. Is equal to angle ABC. That's what we know. This angle here, BAC, the one we're looking for, is equal to ABC, is also equal to that. But it doesn't end there. When you add this angle, that angle, and that angle gives us 180. So we can say BAC, this angle BAC, when we add this angle plus ABC, which is ABC, we also add to ACB. To ACB must give us 180. You see, mysteries have started unfolding. Now, we know that BAC and ABC, this angle here and this angle are the same. So let us just take an assumption that, okay, maybe let's say let angle BAC be equal to x. BAC, we put x here. So if we put x here, and because the angle here and the angle here are equal, so we're going to put also x because they are the same. So that BAC x plus ABC x, so we're going to have 2x, which must be added to ACB. They've given us 50 and must be equal to 180. Of course, we get the 2x and bring it here, so we can have 2x is equal to, this guy now has to go there. And when 50 is subtracted from 180, gives us 130. Finding the value of x, we divide by 2, and x will be 2 into 13, that is 6, remainder 1, 2 into 10, that is 5. So the angle here is 65, and the angle here is 65. Of course, this is just one way of demonstrating. Like if you have understood these angles in the right way, all these procedures are not even important. All these procedures are not even important. The only thing you can do, if you understand these angles, I was just showing this for the sake of having a full understanding. If you understand the angles, we're just going to say that angle BAC, this BAC must be equal to, we have this, we subtract from 180, so we're going to say 180 minus 50. The answer you're going to have, once you subtract this from 150, the answer will remain with is for this angle and that angle. But because they are the same, so you just divide by 2. And when you subtract that, you're going to have 130 by 2 gives you 65. And that is how this work is done. It's so important that we understand the angles that are given. Okay, so 41 minutes. Let's look at the last one. The last one is coming from an ECZ past paper. The last one is coming from an ECZ past paper. The ECZ past paper is the which year? That's 2019. So let's see how we can go back to a 2019 past paper and trace this question and definitely find it. So the way I write questions from the past paper, I write the subject code for 02. Stroke 02 means coming from the past paper, paper 2, and then the year is 2019. How is the diagram? The diagram is like that. There's K here, L, and M. And they've put that, showing that this line, that line is equal, producing 3x minus 65. That is the angle. And the angle here is 2x minus 20. Now there's a statement saying this angle is equal to that angle. Find the value of x. Now here the approach is different. There's no need of saying the total gives us 180. All that is not important. One thing you know for sure is that this angle is equal to that angle. Now, what angle do we have here? We have 3x minus 65, which must be equal to 2x minus 20. Of course, that's the approach. We equate this angle and that angle. Now you see, these guys are like terms just like these are like terms. So the first thing I will do, get this guy who got x comes here, and this guy who doesn't have x goes the other side. So this goes here, that goes there. And we will have 3x, 2x is positive. He gets here will be minus 2x equal to, and 220, the 20 is negative, negative 20. And this guy is negative. He gets here, he'll become positive 65. So that 3x minus 2x will give us x, and then that equal to two different signs you subtract, get a sign from the bigger number, according to the law of algebra. So two different signs, subtract, try to get a sign from the bigger number, and when you subtract 20 from 65, will give us 45. And between the two, which number is bigger? 65 is big and the sign is positive. Therefore, the value of x is equal to 45. So I think that's where we can end for today. That is where we can end for today. There are questions? If there are questions, you can just send me a text here on the top chat, and then I'll be able to attend to it. For now, bye-bye.